here are the derivative of all the inverse trig functions, and here is the list of all 6 of them. And notice that just like the regular trig functions, those co-functions are negative. So let's look at an example involving the arcsecant function. So I have this product of x and the arcsecant of x cubed. So I'm going to use the product rule at first, and then I'm going to use the chain rule on this arcsecant factor. So I have the derivative of x times that second factor, so it's this 1 times arcsecant x cubed, plus the first factor times the derivative of the second factor. So here's where I'm using the chain rule. So I'm using that newly derived derivative formula for arcsecant. So notice it's 1 over x times the square root of x squared minus 1. So I'm replacing x with x cubed because that's my inside function. And so this factors the derivative of the outside function, arcsecant, times the derivative of the inside function, which is 3x squared. And notice that the x cubeds in the numerator are going to cancel with this x cubed. And here's my result. Example 2, now I'm going to be using the arcsine derivative. So again, this first term, I'm going to use the product rule. So for the derivative of the first times the second, I just get the arcsine or inverse sine function, plus the first times the derivative of the second. So going back here, this is the derivative of the arcsine function. And notice my the argument to that was just x. Plus, I have this term where I'm going to use the chain rule on again. The outside function is a power function with a power of 1/2. So now when we simplify this, notice that these terms actually go away. And so this just turns into, simplifies to the inverse sine of x. So in summary, implicit differentiation is just a way to find the derivative of y with respect to x when you can't solve for y in terms of x. So it's differentiating term by term and using the chain rule on any instances of x you see in an equation. And remember that the expression for the derivative can be in terms of x and y. And then using implicit differentiation, we derived the derivatives for the arc or the inverse trig functions.